Good morning, students. Myself, Vijay Shankar from ECE Department, Dielectric College. Today, I am going to discuss about another Maxwell's equation, that is modified Amperes circuit law. In the Maxwell's equation, the first law is del dot d bar is equal to rho v. The Gauss law of electrostatics or electric field. In magnetostatics, the Gauss law of magnetic field del dot b bar is equal to 0. And the Faraday's law del dot h bar is equal to minus dou b bar by dou t. And the fourth one is a modified Amperes circuit law. Modified Amperes circuit law. See the modified Amperes circuit law. We know already the Amperes circuit law del cross h bar is equal to z bar. For static electromagnetic fields, according to the Amperes circuit law, we can write as del cross h bar is equal to z bar. We got this from the Amperes circuit law with the h bar dot dl bar is equal to h bar dot dl bar is equal to I enclosed. I enclosed. What is the I in terms of the current density? The integral j bar dot ds bar. I is equal to j bar dot ds bar. And in the left hand side, the h bar dot dl bar. So convert the line integral to the surface integral. It becomes of a curl function del cross h bar dot ds bar is equal to integral j bar dot ds bar. So on both sides, the surface integral with dot. Remove that surface integral and write as del cross h bar is equal to z bar. Okay. For a static electromagnetic field, according to the Amperes circuit law, we can write as del cross h bar is equal to z bar. On both sides, you can apply the divergence del dot del cross h bar is equal to del dot z bar. Okay. We know according to the property of a curl function, divergence and the curl is always a 0. So 0 is equal to del dot z bar. What is a del dot z bar according to the continuity equation? Del dot z bar is equal to minus dou rho v by dou t. Dou rho v by dou t by using the continuity equation. Okay, my dear students. See, from this equation, the del dot z bar is equal to minus dou rho v by dou t. It is clear that when del dot dou rho v by dou t is equal to 0, as of del cross h but del dot z bar is equal to 0 means minus dou rho v by dou t is equal to 0, and dou rho v by dou t is equal to 0. And this equation is not compatible. This equation 2 and equation 3 are not compatible for the time varying fields. Means with respect to the time, dou rho v by dou t is not compatible. So we can modify the equation 1, that is del cross h bar is equal to j bar is modified by adding the unknown term. Say that it is a n bar. See the n bar. Okay. For the time varying field, so these two functions are not compatible. So we're adding the term for the del cross h bar is equal to z bar. We already know. We can add the n term n bar. We can add the n bar. Got it, my dear friends? That is a modification. Modified Amperes circuit law, and derive the expression as we can add the del cross H bar is equal to J bar dot J bar plus N bar. Again, here you can take the the del cross H bar is equal to J bar plus N bar. We're modifying the J bar and we can add the N, which is not compatible with respect to the time varying fields. Again, you can apply the dot on both sides. So del dot del cross H bar is equal to del dot J bar. According to the distributive law, again it is a del dot J bar dot del dot N bar. The properties saying that the divergence and curl is always equal to the 0. The function is a 0 here. 0 is equal to del dot J bar plus del dot N bar is equal to 0. What is a del dot J bar is equal to? According to the continuity equation, del dot J bar is equal to minus dou rho V by dou T. Dou rho V by dou T. Got it, my student? You can substitute the del dot J bar as minus dou rho V by dou T in that equation, above equation, minus dou rho V by dou T is equal, not is equal to plus del dot N bar. Now, what is the del dot N bar now? Del dot N bar is equal to minus dou, not the minus, so you can get it in the left hand side, it's a plus dou rho V by dou T. Got it, my students? Now, what is a rho V according to the first Maxwell's equation? Del dot D bar is equal to rho V. Now, substitute the rho V as a del dot D bar, and the del dot N bar is equal to dou rho V dou T. Substituting the rho V as del dot D bar. Okay. Now, del dot N bar is equal to, keep that in the inside, del dot dou D bar by dou T. Dou D bar by dou T. On both sides, we can remove the del. What is the N bar is equal to? N bar is equal to dou D bar by dou T. Dou D bar by dou T. Now, that is modified, which is not compatible when we are taking the del dot, not the del dot, del cross H bar is equal to J bar. To add the N bar term, that N bar we got the dou D bar by dou T. What is the final equation now? Del cross H bar is equal to J bar plus, now the N is dou D bar by dou D bar by dou T. Okay. Means this total equation, the del dot J bar or the del cross H bar is equal to the current density J bar. In that current density, the first term here is a JC bar and the second term is a JD bar. Conduction current density and displacement current density. But the JC is sigma into E bar. You know, this is one of the formula, the J into the current density and the electric field intensity. Sigma into E bar plus dou D bar by dou T. What is the dou by dou T of D bar? D bar in terms of the E bar is, so D bar is equal to epsilon into E bar. Okay, so epsilon into E bar. Now the del cross H bar can also return in the terms of the E bar, and del cross H bar is equal to J bar plus dou D bar by dou T, or otherwise we can also call it as a del cross H bar is equal to JC plus JD. Right, my students? JC plus JD. You see here. Now the del cross H bar is equal to JC plus dou D bar by dou T. The first term in the equation is conduction current density denoted as JC bar. Here attaching the subscript C indicates that the current is due to the moving charges. The second term in the equation It represents the current density expressed in the amperes per meter per square meter. As these quantities are planned for time varying field, time varying electric flux density, this is also called as a displacement density or displacement current density, JD bar. Thus, the term is called displacement current density, denoted as JD bar. With this definition, we can write the equation as del cross H bar is equal to JC bar plus JD bar. Okay. And that JC and JD is also converted into the sigma into E bar. Let us see that also equation directly. Let me show. The sigma into E bar and dou by dou T of epsilon into E bar. Okay. I will explain that function. We go to all the four Maxwell's equations. That four Maxwell's equations are, one is del dot D bar is equal to rho B, and del dot B bar is equal to 0, and del cross E bar is equal to minus dou B bar by dou T. We want the Faraday's law. And now we derive the expression, one of the Maxwell's equation, del cross H bar is equal to JC plus JD. That JD is dou D bar by dou T. So the four Maxwell's equations in the point form. Point form is a very, very, very important part, students. Okay. The next, displacement current and the displacement current density. Consider a parallel circuit of resistor and a capacitor given by a time varying voltage B, and through the resistance I1 current, through the capacitor is I2 current. Let the current flowing through the resistor is be I1 and the current flowing through the capacitor is I2. The nature of current flowing through the resistance is different than the flowing through the capacitor. I1 is equal to B by R. I2 is equal to C into dV by dt. In terms of the voltage, we can apply I is equal to V by R and I2 is equal to through the capacitance C into dV by dt. The current flow through the capacitor due to the actual motion of charges. Thus, the current through the resistance can be written as I1 is equal to V by R. This current is called conduction current. This current is called the conduction current. As the current is flowing because of the actual motion of the charges, let it is denoted by the IC. Okay, let it is denoted by the IC. Let A be the cross-sectional area of the resistor, then the conduction current density is given by JC is equal to whatever the current passing through the surface, nothing but the area IC by the A. The J is equal to IC by A. And JC is equal to sigma into E bar. This is one of the formulae. JC is equal to sigma into E bar. Now assume the initial charge of the capacitor is a 0. And for time varying voltage applied across the parallel plate capacitor, the current to the capacitor is given by I2 is equal to C into dV by dt, where V is the voltage. Let the two plates of the area A are separated by distance B, with the dielectric having permittivity epsilon between the plates. Then we can write as C is equal to epsilon A by D. Okay, my dear student. Substitute that in the I2. I2 is equal to C is epsilon A by D into dV by dt. Into dV by dt, where A is the area of the plates and D is the distance between the two parallel plates, and epsilon is the permittivity. Now this current is displacement current. I2 is the conduction current not the sorry, I1 is a conduction current. I1 is a conduction current, so it is represented as IC, and I2 is a displacement current. It is denoted by the ID. The electric field produced by the voltage applied between the two parallel plates is E is equal to V by D. Okay, E is equal to applied voltage and the distance between of the two. V is equal to V, E is equal to V by D, and V is equal to D into E. Substitute here. ID is nothing but the I2. The current, whatever we are I2 current is a displacement current. ID is equal to epsilon A by D, D by dt of V, epsilon A by D, D by dt of what is the V here? In terms of the applied voltage, E is equal to V by D. Okay, and the V is E into D. D is a constant, so bring it is outside D, and D by the dt of E. Okay, my GD get cancelled. So ID is equal to displacement current ID is equal to epsilon A D by dt of E. And we know JC is equal to IC by A. Similarly, the JD is also displacement current density, the current density displacement current by the A. What is the ID now? We got epsilon A into D by dt of E by A. So A get cancelled. JD is equal to epsilon D by dt of E. JD is equal to, when it is a JD bar vector, you can keep these also the vector. JD bar is equal to epsilon into E bar. And now write the inside the JD bar is equal to D by dt of epsilon into E bar. So what is the epsilon into E bar? The relation between of the electric field and the magnetic field, or the electric field and the electric flux is epsilon into E bar. So JD bar is equal to D by dt of D bar, or you can write as a partial derivative dou by dou t of D bar. JD bar is equal to dou by dou t of D bar. Got it, my dear students? In the Maxwell's equation, modified Ampere circuit law, Maxwell's equation, del cross H bar is equal to, first one is a JC, conduction current density, plus JD, displacement current density. JD now we got is a dou D bar by dou T. Dou D bar by dou T. And JC we already know the difference. JC is equal to, see this is a JC here. JC is equal to sigma into E bar. JC is equal to IC by A, and that is a sigma into E bar. So del cross H bar is equal to sigma into E bar plus dou D bar by dou T. Got it, my students? JD is equal to dou D bar by dou T. Thus, in a given medium, both the types of currents, namely conduction current and displacement current, may flow. Hence, two current density can be written as JC is equal to sigma into E bar, conduction current density. JD bar is equal to dou D bar by dou T, displacement current density. And the total current density is given by J bar is equal to JC plus JD. Okay, JC plus JD. Now, some materials are good conductors while some are perfect dielectrics. But in some materials which are neither good conductors nor perfect dielectrics. Okay. Both the currents, namely conduction current and the displacement current, may exist. For the electric field E bar, the time dependence is given by the e power j omega t. Then the total current density is given by J bar is equal to JC plus JD bar. Okay, that JC is sigma into E bar and JD bar is dou D bar by dou T, and dou by dou T of D bar is nothing but epsilon into E bar, and sigma into E bar plus, here the Y they written as dou by dou T of is J omega. Okay. Now let us what they are saying here. For electric field intensity E bar, let the time dependence is given by the e power j omega t dt. E power j omega t dt means, see, if I am taking the E bar is equal to e power j omega t. E bar is equal to e power j omega t. Got it, my students? And dou or whatever it is, a d by dt, whatever it is, dou by dou t, dou e bar by dou t is equal to now apply the derivative here, e power j omega t into, with respect to the t we are applying, what is the coefficient of t is j omega. Got it, my student? J omega. So what is the e bar here? E power j omega t, nothing but dou by dou t e bar is equal to e power j omega t. Again, you can substitute that as a e bar j omega. Now see, what is a dou by dou t? Nothing but a j omega 1. So wherever the dou by dou t is there, you can replace the j omega. Got it, my students? So sigma into e bar plus dou by dou t is replaced with the j omega into epsilon e bar. Then the ratio of the magnitudes of conduction current density to the displacement current density is given by the value of sigma e bar is a JC, and this value of j omega epsilon into e bar is a J, and the ratio between of the conduction current density J bar by the ratio to the displacement current density, both its a magnitude, we can take what is a JC, sigma into e bar, and take the magnitude only. There is no real term. There's this one is the imaginary term. So I take only sigma by, both having the e bar is there, coefficients of e bar sigma by, and the j is omega epsilon, the real term and the imaginary term coefficient. JC bar by the JD is equal to sigma by omega epsilon. It's a very, very important equation, my dear students. Coming chapter, the EM characteristics 1 and the EM characteristics 2 totally depends upon this equation only. The total chapter, electromagnetic characteristics 1 and electromagnetic characteristics 2, total is depends upon this equation only. JC bar by the JD bar is equal to sigma by the omega epsilon. And this sigma by the omega epsilon is very much greater than the 1, and sigma by omega epsilon is very much less than the 1. So saying it is a which one is a perfect dielectric and which one is a perfect conductor. Sigma is a conductor here and epsilon is a dielectric. The first equation saying that sigma is very much greater than the omega epsilon and cross multiplying here. Means sigma is very much greater than the omega epsilon means compared to the dielectric, the conductivity is more. This is a conductivity, my dear students. Sigma is a conductivity and epsilon is a dielectric. Okay, the equation saying that sigma is very much greater than the omega epsilon means dielectric is very, very less compared to the conductivity. So it is a perfect conductor. This equation satisfies that sigma by omega epsilon is greater than 1 means perfect conductor. Perfect conductor. And the second equation saying that is a perfect conductor. Second equation saying that sigma is very much less than the omega epsilon. Means the conductivity is compared to the dielectric is very less. So it is a perfect dielectric. Perfect dielectric. Okay, the perfect dielectric. Sigma by the omega epsilon, the ratio between of the conduction current density and the displacement current density is very much greater than the one that we can call it as a perfect conductor. It's very much less than, greater than 1 is a perfect conductor, less than the 1 is a perfect dielectric. From the above equation, it is clear that the ratio of magnitudes of the current density depends upon the constants of the media, sigma and epsilon, and the frequency omega. When the value of ratio is sigma by omega epsilon is very much greater than the 1, then the medium considered as a perfect conductor, see here, is a perfect conductor. This medium is considered as a perfect conductor, what we are saying. Thus, the conduction current density is greater than as compared to the displacement current density. Means definitely JC is greater than the JD. The conduction is more. So it is a perfect conductor. While if the second one saying that, while if the value of ratio is sigma by omega epsilon is very much less than the 1, then the medium can be considered as a perfect dielectric. See, this is a perfect dielectric. For the dielectric medium, the displacement current exceeds the current density, conduction current density. Compared to that, as a ratio of depends on the frequency, which is perfect conductor at low frequency, maybe turn out to the perfect dielectric at very high frequency. The medium which is a perfect conductor at low frequency may turn out to be a perfect dielectric at very high frequency. Very good, my understood, my students. So very, very important equation is. The next general field relations for the time varying electric and the magnetic fields. We know the one of the Maxwell's equation, the Faraday's law, del cross E bar is equal to minus dou B bar by dou T. Okay. These are the equations we get for the general equations. I will explain this one. So in a B bar is equal to, we already studied that there is a relation between of the vector magnetic potential and the B bar. The B bar is equal to del cross E bar. So del cross E bar is equal to minus dou by dou T of del cross B bar. Interchanging the operators, the RHS, so we get del cross E bar is equal to, you can write in the inside, minus delta del cross dou E bar by dou T. And bring that into the left hand side, del cross E bar plus del cross dou A bar by dou T is equal to 0. And common term here, the del cross E bar plus dou A bar by dou T is equal to 0. What I call the vector identity, curl of gradient curl of gradient of a scalar is always a 0. Curl of a gradient of a scalar is always 0. Del cross if it is a scalar. We know del cross, this function, the total function as a gradient, as we can write as E bar plus dou A bar by dou T is equal to minus del V. Okay, as RHS of the equation of the 3, including curl is a 0, we can introduce a negative sign in the right hand side, that is a minus del V minus dou A bar by dou T. You can write as a minus E is equal to minus del V minus dou A bar by the dou T. E bar is equal to. Now when the field is a static, dou A bar by dou T is equal to 0. Hence, we get the basic gradient relationship as E bar is equal to minus del V. We can also derive the gradient of V by using Faraday's law. Del cross E bar is equal to minus dou B bar by the dou B. The E bar is equal to minus del V. Okay. And in the closed surface, if the current is flowing out of the surface, I is equal to dq by dt. Current is nothing but the change of charge with respect to the time only. Okay, coulomb per seconds or ampere. A current is flowing out of the surface. It indicates that the positive charge is going out, so that the positive charge is decreasing internally. Let the Q1 be the internal charge, I is equal to, and is decreasing the internal means minus dq by the dt. We know the Q is equal to, in terms of the volume, is rho v dv. dq is equal to dq by dv is equal to rho v actual. Apply the integral on both sides. So Q is equal to integral rho v dv. So I is equal to minus d by dt of, already substitute the Q1 here, minus d by dt of integral rho v dv. Integral, bring that is a derivative inside. Actually, it is a dou by dou t, right? Whenever you can bring that the derivative part in the inside, I is equal to minus d by dt of integral volume integral rho v dv. That is equal to the volume integral dou rho v by dou t into dv. I is equal to. Okay, my dear friends. But the current is expressed in J bar dot ds bar. What is I is equal to J bar dot ds bar, integral J bar dot ds bar. That is equal to integral volume integral. This is a surface integral. It's not the volume integral. There's something wrong is that I is equal to integral J bar dot ds bar. Dou rho v by dou t into dv. Okay. From these two equations, I is equal to minus integral. The minus is also there, minus students here. Minus is there. Minus integral volume integral dou rho v by dou t into dv, and surface integral J bar dot ds bar, equating the two functions. Equating the two functions. See here also something went wrong. It is not the volume integral, my students. It is a surface integral. So surface integral is converted to the volume integral, then only it is a volume by using the divergence theorem. Surface integral is converted to the volume integral by the del dot J bar into dv. Now it becomes a volume integral is equal to, in the right hand side also, volume integral, that is dou rho v by dou t into dv. On both sides is the volume integral, del dot J bar is equal to minus dou rho v by dou t. Nothing but it's a continuity equation, my students. It is also very important as an examination point of view. Del dot J bar is equal to minus dou rho v by dou t. The continuity equation. Okay. So equation 11 is called the equation of the continuity of current in a point form or differential form. Got it, my students? So we derived by using by taking the I is equal to the current I is equal to the change of charge with respect to the time. That charge, whenever if it is in the inside, indicates that the positive charge is going out. So the positive charge is decreasing internally. Let the Q1 be the internal charge. I is equal to minus dq by dt. We know the Q is equal to in terms of the volume charge density, integral rho v by rho v into dv, and equate, substitute in the current. And I is also know that J bar dot ds bar, simplify, and finally you get the continuity equation. Del dot J bar is equal to minus dou rho v by dou t or d rho v by dt. Got it, my students? And another one, Amperes circuit law, the point form. Del cross H bar is equal to Z bar. Apply the divergence of both sides. Del dot del cross H bar is equal to del dot J bar. The divergence and curl is always a 0. Del dot J bar is equal to 0. Is valid only for the static fields and not for the time varying fields, my students. For time varying field, we must modify the above equation to have the property valid is del dot J bar is equal to minus dou rho v by dou t. So del dot J bar plus dou rho v by dou t is equal to 0. For the time varying fields, del dot del class H bar is equal to del dot J bar plus dou rho v by dou t. And you can substitute the rho v as del dot t bar, and it becomes of del dot J bar plus dou by dou t of del dot t bar. So rho v as del dot t bar. Okay. So del dot del cross H bar is equal to del dot J bar plus, bring that inside, del dot dou d bar by dou t. Okay, on both sides there is a del, means del cross H bar is equal to J bar into dou d bar by dou t. It is also the modified equation of del cross H bar. Okay, like that we can also derive the modified Amperes circuit law from the del cross H bar. Okay. Del cross H bar is equal to valid for the static fields only, but for time varying fields, we can add the n bar. Otherwise, directly like this, we can derive the expression of del cross H as dou d bar by dou t. Okay, where J is a JC bar and the dou d bar by dou t is a JD bar. Displacement current density and conduction current density.